You are welcome with us, so we are really very happy to see you again with us. Thank you for your visit.
Hello, good morning everybody. I'm sorry I talk in English. I hope, but I talk slowly and I hope eventually I will finish and you will understand me. I come back to the classic major autoimmunotherapy, autosystemic. And I would like to talk a little bit about the rationale. What is ozone doing? How does it interfere in the special indications? And so you have heard a lot about mechanism of action already. And so I want to summarize it. We have two mechanisms, two main mechanisms. One is the direct mechanism, where oxygen kills bacteria, germs, fungi, whatsoever. So this is used in medicine, of course, as well, via oxygen radicals, H2O2 and so on. We use the bactericidal effect in topical treatment, what you have seen in wound cleansing, in diabetic food, in ulcerative colitis. Here we take from our concentrations, which are going from 1 to 100 microgram per mil, we take the high concentrations. The high concentrations for the direct effect of ozone for wound cleansing. If you want to get wound healing, you must reduce the concentration dramatically. And this is the concentration range we use for systemic effect of ozone, for wound healing, for cell metabolism, activation and so on. But here we have an indirect reaction of ozone. No radicals, no free radicals, no H2O2, but we have, as we call it, this ozone peroxide. I will show you the difference between the ozone peroxide and the oxidative stress situation. So we take this mechanism for bioregulation, for the systemic effect, for systemic treatment, for wound healing, and for all the ozone indications which are under the headline of chronic inflammation, chronic inflammatory processes. So these again are our concentrations. We use all of them. High one for topical treatment with radical effects, H2O2 and so on. Low concentration with non-radical effect via the ozone peroxide. For wound healing as well as for all the systemic treatments like major autohemo and rectal insufflation. Here we know that for a long time that you clean the wound with high concentrations, but if you keep up taking the high concentrations, you will never close the wound. You must reduce it to, let's say, around 20 microgram per mil, and then you will get the wound healing. So, what is the situation of all our ozone indications? You have heard that already. We have the headline, chronic inflammatory diseases. What is a common thing of everything, of all of them? High oxidative stress. So we have you have seen it already, an excess of oxidants and an insufficiency of antioxidants. So this disbalance is a problem of all the diseases, indications, angiopathia, diabetic angiopathia in particular, chronic inflammatory processes such as rheumatoid arthritis, which we never thought is a real good ozone indication, and of course all the age-related diseases and especially age-related cancer, and all of them have the high oxidative stress and an insufficiency of the antioxidants. Finally, they produce the OH radical, and the OH radical destroys everything in the body, which is a normal biological reaction. If you get an infection, you have the same situation. But finally, in a healthy biological system, you come back to the balance. Why? The antioxidants are reproduced and activated again. In a chronic inflammation, this is not possible. But now, you give ozone. Ozone is an oxidant. Ozone is a strong oxidant. And you have already high oxidative stress. How does ozone interfere? You must, this is a question your patients will ask you. Why do you give another oxidant? And that's what we want to see. So what happens with ozone in systemic treatment? Low dose, 10 to 40 in major or in rectal insufflation. Ozone reacts immediately if you give it to the blood with the cell membrane to short chain peroxide. It splits it here. This is a special ozone peroxide. It's immediately reduced by the glutathione system. So, there is no H2O2 in the blood. And this peroxide now acts like a second messenger substance. That means it reacts with glutathione, and this is the key reaction. It gives the information via the nucleofactors. Red blood cell is different, of course, has no nucleus, but all the other cells have a nucleus, and this reaction gives an information to the nucleus via the nucleofactors. Be careful, there is an oxidant which is not a body's own or the biological one, and now the regulation starts again. So, in your patients, the regulation does not work anymore. And now we give this short peroxide, this small peroxide, and the regulation will be induced again. And so there must be a difference between chronic stress, oxidative stress, and this peroxide. So, and you know of course already, you have heard that several times, with immune competent cells, the mechanism, the information is the same. There are other partners, other nucleofactors and so on, but the information is given to the nucleus and is given to the DNA, and special parts of DNA are activated, and the production of cytokines, of immune specific substances starts. So finally, we measure an immunoregulation and we measure a cellular redox regulation. It means antioxidant regulation. In the red blood cells it's a little different. We have a better oxygen release. You have heard that already. So, what is that? The specific. We give an oxidant to high oxidative stress. And I want just, sorry, a little bit of chemistry, just to show you what means high oxidative stress in the body. There are different substances you can measure. One very characteristic one is hydroperoxide. So what is the difference? It's a reaction of oxygen we breathe. You cannot avoid oxidative stress in the body because we use oxygen, we need oxygen. But oxygen can react with polyunsaturated fatty acids, which are so famous and are said to be healthy. And we get a peroxide which is stable, which is much more stable than our ozone peroxide. It is stable in the body, you can measure it, you can take it as a reference substance in the body for oxidative stress. We call it then total hydroperoxide, which you measure, or your laboratory can measure, and you have a measure for oxidative stress in your patient. So the ozone peroxide is very small, you see the difference. OH radical is at the end. And here it's in the middle, it's protected. That's the reason it's so stable. This is not stable. It reacts immediately and it will be reduced by glutathione. This is measured and measured again. So we produce a different peroxide which is able again as a reaction. It's not very stable. The reaction with glutathione can take place and we regulate our antioxidants. Finally, we upregulate the antioxidants. This is the main. So, please, why low concentration? I will explain what you know. This is glutathione, our ozone peroxide. It's reduced in the cell by the glutathione system, and the glutathione, of course, is then oxidized from GSH, as we normally call it, to GSHG. Now, why low dose? If you have a high concentration of this, you oxidize, and the reduction by the enzymes cannot take place anymore. So if you destroy the GSH balance, then you have overdosed. And you can measure that. If GSH goes down during your treatment, then please think about the dose and the concentration you have given. Okay? This is the main reason. This is the limit. The GSH is the limit for the dose. For systemic, we are talking about systemic ozone. So we can easily measure that, and it's not new. So in a lethal peritonitis in an animal model, it's not new. It's already done published in 2003. What I tell you here is everything is published.
Please speak aloud because in the back of the floor nobody hears you.
Then it's the microphone, maybe. Okay. Okay, so you can see here, in animals it's always easy. You measure the survival time, survival rate of the animals. And in lethal peritonitis you normally hear from 10 animals, 1 will survive. With ozone treatment in advance, in prevention, you have with air as a control, some more survive, with 100, a concentration of 100, and with a concentration of 10 microgram of ozone, most of them survive. So here in this case 60%. So that means the low concentration is the one which activates and which helps for the regulation. And in nephrotoxicity, again, I show you the GSH, how it develops in such a treatment. This is a GSH, glutathione, in acute nephrotoxicity treated with ozone. Nephrotoxicity control healthy after chemotherapy in the kidney. GSH goes immediately down, and by treatment with ozone, 10, 30 microgram per minute goes up. So we really help, we reverse the nephrotoxicity, and with 50 you can see it goes back again. So with a concentration of 50 in systemic treatment starts to be toxic. And in aging process, I just take the liver. The liver is the organ which responds the very, very best to ozone, liver and kidney. And you can see here aging process. GSH in a normal aging, this of course can only be done in animals. This is a normal, healthy aging process of mice, and you see the GSH goes down by aging, and these animals had been pre-treated, the green one, by ozone over 14 months, the whole life, and you can see that the GSH is up the normal range. So GSH is the key function because it's the most important antioxidants we have in the body. Another point is, or at the same time, we have a liver protection. Liver protection measured. You can measure that always. We have already seen it before as gamma GT in the liver, and you can see under therapy with MTX. These are rheumatic. This is the point here. This is in rheumatoid arthritis patients where all of them are under MTX, and you can see how the liver, the gamma GT in the liver is high under the MTX patients, and these patients got additional ozone. So we have a liver protection of MTX, and what is behind? Again, same mechanism, always the same. I'll show you another point. Prevention of synovitis. Prevention of synovitis. This GSH, healthy, chronic inflammation or inflammatory process, synovitis. We have high oxidative stress, the long-chain peroxides. Now the next group is treated with ozone, pre-treated in this case. This is our ozone peroxide, and we get a reduction of the oxidative stress. Now, with oxygen, we don't get any reduction. Why? Oxygen itself is a radical. We always forget about it. Oxygen is a radical, and so it helps, it contributes to the oxidative stress. I think I go further because it just shows that major autoimmunotherapy and rectal insufflation are evidence-based today. You can go, we have published that. The low-dose ozone concept in form of major autoimmunotherapy and rectal insufflation is effective, safe, standardized, and has no side effects. That is the result of the clinical evaluation and the evidence-based, evidence classification of major autoimmunotherapy and rectal insufflation, both of them. We find grade A, referring to level 1B studies, 1B, and of course hygiene standards have to be followed, materials must be ozone resistant, and the guidelines have to be followed as well. So we have published the guidelines for everybody, you can get them. We have also published the evidence-based study. You can also get it here, when you will find there all the information about the publications which had been evaluated. Just take the title, go to the internet, and you will immediately come to the journal. So these systemic ozone treatments under low-dose ozone concept is evidence-based today and has a very good scientific background. Thank you for your attention.